Hi student, this is Sivakumar. 11th standard mathematics chapter number 3 continuation of exercise 3.2. Now problem number 8. The perimeter of a certain sector of a circle is equal to the length of the arc of a semicircle having the same radius. Express the angle of the sector in degrees, minutes and seconds. Okay. Here is the question. The perimeter of a certain sector of a circle is equal to length of the arc of the semicircle. I considered for this circle, let R be the radius of the circle, let O be the center of a circle. I consider this sector OAB. Okay, theta 1 is the central angle of this sector OAB. This is the minor arc of the sector. And here this portion, it is a semicircle. Both have the same radius. So OA is R, even OC is R. Same radius that is given in the question itself. Since it is a semicircle, here theta 2 represents the central angle of the semicircle. You know that theta 2 that is equal to 180 degree. Because semicircle angle is 180 degree, right? You have to find out theta 1 only. You have to find out theta 1, theta 2 is given. Okay, what I mentioned here. Let theta 1 be the central angle of the sector with arc AB. Theta 1 be the central angle of the sector with arc AB. Theta 2 be the central angle of the sector with arc CD. For arc CD, what is the central angle? Theta 2. Same radius. Let R be the common radius for both the sectors. I consider arc AB that is equal to S1. Arc AB that is equal to S1. And arc CD that is equal to, I consider as S2. Again I tell you, arc AB as S1. This is S1. From here to here. From here to here, arc CD that is S2. Okay. Here theta 2 that is equal to 180 degree. I note down here theta 2 that is equal to 180 degree. Can write the theta 2 in radian, that is equal to 180 into pi by 180. For converting degree into radian, multiply by pi by 180. 180 get cancelled, that is equal to pi. Theta 2 that is equal to pi radian. Given perimeter of a sector having the central angle theta 1 that is equal to length of the arc of a semicircle. Length of the arc of a semicircle having the same radius. Having the same radius. Right. This is the condition given. Perimeter of the sector. Perimeter. Consider the sector. Perimeter means start from here. OA length plus AB arc length plus BO. So R plus R, 2R plus S1. 2R plus S1. Which implies 2R plus S1 that is equal to length of the arc of the semicircle having the same radius. That means S2. Length of the arc of the semicircle, what it is? S2. That is equal to S2. which implies 2r plus s1 formula r into theta. Here instead of theta I have to write theta 1. Radius r only, we have taken that theta 1 is the central angle for this sector. For the right hand side s2 formula r into theta, or no change at all, radius only. Instead of theta I have to put theta 2. Theta 2 is the central angle for this sector, which implies 2r plus r theta 1, that is equal to r into theta 2, that is equal to 180 degrees. We have changed 180 degree into pi radian. Here it is. So r into pi. Now divide by r first. Divide. If we divide by r get cancelled 2. R get cancelled theta 1. R get cancelled pi. So we have to find out theta 1. Theta 1, that is equal to pi minus 2. Plus 2 comes right hand side, minus 2. Pi value, you know that 22 by 7 minus 2. That is equal to 22 minus 14 divided by 7. What is the LCM? 7 is the LCM. So we will be getting 14. 22 minus 14 divided by 7. 22 minus 14, that is equal to 8. 8 by 7 radian. Theta represents radian here, but you are asked to write the angle in degrees, minutes and seconds. So for converting this radian into degrees, 8 by 7 into 180 divided by pi, multiplied by 180 by pi, that is equal to 8 by 7 into 180 divided by this pi can be replaced by 22 by 7. That is equal to 8 by 7 into 180 into 22 by 7, reciprocal 7 by 22. Division become multiplication. 22 by 7 is 7 by 22. Reciprocal is 7 by 22. 7 get cancelled. 2 table 4 times, 11 times. That is equal to 4 into 180, that is 720 divided by 11. 720 divided by 11. You have to divide now. I do the calculation here. 720 divided by 11. 11 6 are 66, balance 6 0. 11 5s are 55, balance 5. Okay. So this can be written as 65 5 by 11. 65 5 by 11. You can write in mixed fraction. 65 5 by 11 degrees. Write the quotient first, then a remainder by divisor, degrees. Have written that improper fraction into mixed fraction. 65 is the quotient, 5 is the remainder, 11 is the divisor. That is equal to 65 degree. For converting 5 by 11 degree into minutes, 5 by 11 into 60. If you multiply it by 60, that will be converted into minutes. That is equal to 5 into 60, 300 by 11. Now I am going to divide 300 by 11. 11 2s are 22, balance 8 0. 11 7s are 70, 7 balance 3. That is 27 3 by 11. 27 3 by 11 minutes. Write the quotient first, then remainder by divisor. 3 by 11 minutes. That means 65 degree 27 minutes. This is degree, minutes. And converting 3 by 11 minutes into seconds, that 3 by 11 should be multiplied by 60. That is equal to 3 into 60, 180 divided by 11. I do the calculation. 180 divided by 11 equals 11 ones are 11, balance 7, 0, bring down 0. 11 6 are 66, balance 4. That is 16, 4 by 11. You write that 16, 4 by 11 seconds. So approximately you can write 65 degree, 27 minutes and 16 seconds. Single dash represents minutes and double dash represents seconds. Approximately. You can neglect that 4 by 11. You just write only 16 seconds. Since I have neglected 4 by 11, I have written that approximately. Okay. This is the central angle. Therefore, the central angle of the sector better to write a required sector equals 65 degrees, 27 minutes, 16 seconds approximately. Over. So problem number 8 is completed. Then I'll be teaching problem number 9 in the next video. Thank you, children.